Welcome everyone to JADAK's Clarity 2.0 software webinar. My name is Erika van der Lely and I'm part of the marketing group at JADAK. On the line we have our presenter Chuck Barber, who is the Director of Product Management at JADAK. Also on the line is Andrew Don, Sales Director Healthcare EMEA, Marco Meulensteen, Technical Director EMEA, and Remco Schiinski, Application Engineer EMEA. At today's webinar, we'll review what Clarity is and highlight its features via a demo to show you the software's ability to match patterns, decode barcodes, detect presence-absence of an object or objects, amongst others. We'll also go over the newest updates to the software, which include the ability to match color and pre-process images. We encourage you to type in any questions you may have into the chat window during the webinar, so I can read your questions aloud to Chuck at the end of his presentation. We will do our best to answer all your questions. However, if time does not allow it, we will email you back the answers to your questions. So now, without further ado, I'd like to hand the mic over to our Director of Product Management, Chuck Barber. Chuck, take it away.
Okay, thank you, Erica. So we're going to go through, as Erica said, we're going to go through our presentation on our Clarity 2.0 machine vision package. This is just a little quick bio on myself. It's me. I've been in the industry a long time, about 20 years of experience in automatic data collection. So barcode, machine vision, and RFID technologies, really. I've been here at JADAK for 8 years. And I have about 30 patents in the imaging space, almost all in imaging for barcode reading and machine vision. So the technologies that we're talking about today. This is our agenda. I'm going to start out with a quick introduction to JADAK, just 2 or 3 slides to give you a little background, but then we'll get right into the meat of the presentation. So JADAK is located here in Syracuse, New York. We have a European office in Breda in the Netherlands. These are the different technologies in which JADAK's involved. And again, today we're going to be concentrating on our machine vision solutions. We're also involved with 1D and 2D barcode reading extensively, RFID. We have a small spectroscopy business and a printer and strip chart recorder business. And generally, our business is targeted as OEM products, really targeted towards the medical device manufacturers. We've done several recent acquisitions over the last 4 years, really. General scanning printers, which is the printers and strip chart recorders, again, meant for medical usage. We have a spectroscopy business. And we've done 2 RFID acquisitions, 2 companies called SkyTech and ThingMagic in about the last year and a half. JADAK is actually part of a larger company called Novanta, and there's really 3 product groups within Novanta. And these products are all primarily targeted towards OEM customers. The roots of Novanta came from products like this, so lasers and galvanometers. So if you define a galvanometer as a laser with a mirror and a motor to steer that mirror to precisely steer that laser for different applications like laser marking and cutting and so on. We have our precision motion group, and really this group is primarily about robotic motion. So you can think of the small motors that are needed to move a robotic joint, and as well as the position sensing equipment to accurately sense where that robotic arm might be at any particular time. And then we have what we call our vision technology group. Well, that's where JADAK is, and we'll talk obviously a bit more about our vision technologies today. There's a company called NDS that makes high color fidelity displays for use in the operating room. And then we have another display company called Reach. I like to characterize these devices as a tablet, but without the case and so on. So that would be a kind of a tablet. So a display in the associated processing that an OEM customer might want to embed within their piece of equipment. Okay, with that little background covered, we're going to talk now about our Clarity 2.0 Machine Vision Assist package. So Clarity is machine vision development software really targeted towards our customers who might want to develop machine vision machine vision algorithms, but they don't have machine vision experience. And actually, maybe you don't even need to be a software engineer in order to use Clarity. So what Clarity does, it allows you to run the Clarity application on a PC with images that you gather either directly from the camera or images that you've gathered ahead of time. And you can develop a machine vision algorithm all using graphical tools like I've shown here in this picture. In this picture, I use Clarity to generate an application where I'm looking at the width of this test tube. So I've detected this side, detected that side, and then measured the width of the test tube. And again, I think the important point here is Clarity allows anybody to develop a machine vision algorithm. You don't have to be a machine vision engineer or a software engineer or an engineer at all, really, as long as you have a reasonable technical understanding of what you're trying to accomplish. We're going to go into a few examples later on. This is our Clarity package, and I'll do just a quick walkthrough of the screen here. So up top, we have the different machine vision functions, or plugins as we call them, and I have them highlighted down here. I'm going to go in a little bit of detail on each one of those in coming slides. This section of the screen would be where you select these different steps and assemble them together to develop a machine vision process or an algorithm. Here is obvious, we have an image display area where you can see how the machine vision is working on the particular image that you're looking at any specific time. And then we have some individual adjustments for each of these different plugins where you can really highly configure how they operate on the image. And again, we're going to go through some more examples later. We'll do a quick walkthrough of our different image plugins now. So first is our PresenceAbsence plugin. And that really, it does just what it says. It's you're really looking for something to be in the image or not in the image. In this case, I did a little example where I'm looking at a test tube and I'm trying to figure out if that cap is present or not in the image. Count, again, does just what it says, where you're counting objects in the image. So in this case, I'm counting pills. And we're actually going to go through the specific example later on when I do the demo. Pattern match is where you're looking for a specific shape in the image. So in this case, this is a biopsy sample. And what this example is doing is trying to compare the shape of the original biopsy to the shape of the biopsy as is placed on a slide to make sure that you have a match and someone didn't mistakenly put the biopsy on a slide that's assigned to a different patient. Decode is a barcode decoding application, and you can set up specific windows to decode barcodes at different points in the image. So in this case, I've set up 5 barcode windows to decode these 5 barcodes and really output them in the order so that you have an association with the barcode data to the position in the image from where it came. Finder and measure are generally used together. And this is the example I showed on the previous slide where I'm measuring the width of the test tube. So you generally use Finder to find objects in the image, and then the measure part goes along with it to measure distances between those objects that you previously found. We have an image pre-processing function, and this is one of the new functions that we've added to Clarity in this version. We've added new features to all these other functions as well, but these two, the image processing and the color, are brand new functions that we added. In this case, I'm using image processing to help assist in the barcode decoding. So this is a case where we had this data matrix barcode, but there were breaks in this finder pattern that made it more difficult for the decoder to decode that barcode. So what you can do is use image pre-processing really to clean up those breaks and really to speed up the barcode decoding process. And then last is color detection. This is the primary new function that we've added to Clarity. And you can use the color detection to identify the color of objects. So in this case, this would be the test tube cap. And in the demo we show later, I'm going to show a different use for the color detect function. I want to talk a little bit about what the development process for a Clarity project looks like. So just like in any kind of engineering project, you have to do your upfront system design first, or just, I always like to characterize it like building a house. If you don't build that good foundation, you're not going to have a good house when you're all done. So you have to do these steps. What kind of camera do you need? What's the distance camera to the target? Design your lighting. What's your system throughput needed? How do you want to interface? And so on and so on. All these different things that you have to consider up front. But once you have that design complete, you usually are going to develop some kind of a test fixture to test your machine vision, or maybe you just go right to building the actual system. Install your camera and illumination, gather some images. And these steps in green is where Clarity comes in. So you would generally, how it would work is you would gather a bunch of images, store them on your PC, and then using the graphical tools that I just ran through with Clarity, you would set up your machine vision algorithm. Once that's all done, you can flash that resulting algorithm, we call it a script, down into the camera, and then you can test right in the camera system. So when you're all said and done, even though you developed that algorithm on the PC, everything runs within the camera later on, so you don't actually need a separate PC. Now, Clarity could also be used with a third-party camera. So generally, most of our customers are going to take that Clarity script and put it into one of the JADAK supplied cameras. And you can see those all on our website. But we could use a camera that's shipping an image to the PC and have the Clarity images run on that PC. And depending on the operating system and so on, our engineers may have to do a little work to help you port that machine vision algorithm to your host processor, but that's all something that could be done. Okay, this is where we're going to get into our demo for the Clarity features. It says live demo here. We actually have a little film that we're going to do instead of a live demo. And I'll switch over to the. I want to apologize that sometimes over the WebEx, the video may not be as high resolution as you might like, but these will all be available on our website after the webinar if you want to look at things in greater detail. In this video, I'm going to try to illustrate as many of the features of Clarity as I can in the limited time that we have available. What I have here is a test fixture that we use at JADAK, and it's a simulation of a lateral flow diagnostics reader. If you're not familiar with lateral flow diagnostics, but they're generally if you think of an early pregnancy test, that's a good example. So you're going to have some kind of a cartridge that you put on blood or urine, some kind of bodily fluid, which then will react and generate some kind of line or some kind of symbol on the cartridge. The cartridges usually have a reference area like this, a reference color, and then they have the reaction color, which shows up if the reaction is positive. And that reaction color can be brighter or dimmer, as I've shown here in this simulation. This first image is just the background in the test fixture that we use. And I think I'm going to start there, and I think the first thing I'll show is our presence-absence step to see if the cartridge is even present in the image. So we're going to add our presence-absence step. Now the first thing you see is you get an invalid image. Well, since I was using color images here, but this step requires a black and white image. So I'm going to add an image process, move that to before the presence step, and then in my image process function I'm going to say convert to grayscale. Now my present step, I'm going to go down here and I'm going to say, well, what image do I want to process? I can use the acquired image, or I can use the image processed image. Now you see that error goes away. Now we can actually begin to work on our presence-absence function. This red box, this region of interest box, shows up on the image, and I'm going to move that to the area of the image that I actually want to process. This is the area of the image where I actually want the machine vision to do its work. Well, I notice that I have these bright pixels here in the image, and I'm going to try to detect those bright pixels, which should go away if the cartridge is present. Okay, since I'm only interested in the bright pixels, I'm going to use these selections. I could either slide or just type in directly to say only look for pixels that are between a value of 255. This is an 8-bit image, so any pixel value can take a value from 0 to 255, and I'm only interested in those very bright pixels that are up at the high end of that range. Then the next thing I'm going to do is, you can see I have about 10,000 of those bright pixels in this particular image, or in this area of interest, I should say. So I'm going to say I only want it to be a pass if I only have a very small number of those bright pixels, say between 0 and 100. So let's see how that works on an image where there's actually a cartridge. Now you can see I had 0 bright pixels, and so that's a pass. Again, a pass, a pass, a pass, and back to my original image. So that worked pretty well. Next thing I'd like to do is illustrate the use of pattern match. And I'm going to use pattern match to recognize this logo in the image. A lot of our customers have a kind of business model where they have a device they sell, but then a lot of the revenue stream comes from the cartridge or whatever disposable goes with that device. A lot of times they want to recognize the logo to recognize that it's actually their cartridge that's being used there and not a counterfeit cartridge. So we'll click on the pattern match. Again, the first thing that happens is I get this train image box that pops up. And I have this green area image that green area of interest that I'm going to move over the feature in the image that I want to recognize. So we'll move that around the logo, and I'm going to accept it. Now back to the original image, this box is the area of the image where I'm going to look for that particular pattern. You could make that the whole image if you want, but in a well-controlled situation like this, you would only need it in the particular area where you expect that logo to show up. Now you can see I had a 100% pattern match for that logo. That's because I'm comparing the trained image to the actual full image from which it came. So I'm getting a perfect match. But in subsequent images, you can see that goes down a little bit, but still a very good match. The next one matches. Now this last image, I doctored up that logo to make it look like it's counterfeit. And you see my pattern match score drops, and with the red border on this step and the red border here in the image indicates that that step now failed, that pattern no longer meets our criteria. Now I could change that. I could change my passing score up or down depending on how loose or tight I wanted that particular pattern match to be. Next, let's try a decode function to decode that barcode. So I'll add the decode, and it's taking the image process step, which is what I want. Again, I get my region of interest. I'm going to move that around the barcode. As soon as I move that around the barcode, you can see the step went green because the decode process saw a valid barcode, and this is the message that's inside. I have a whole lot of other settings here. I have all these linear codes, which again, in this application, I never expect to see those, so I would probably turn those off. A bunch of 2D codes. I'm only have this Aztec code, so I'm going to shut those off. And so on. And there's a lot of other settings that are described in our online help and in our other videos that are online where you can see a bit more about how these work. Okay, the next thing I'm going to do, let's actually run that through the other images to make sure it decoded on all of them. And that all worked. The next thing I'd like to do is actually start processing these colors on this lateral flow diagnostic strip. So I'm going to add a color detection step. Well, because I had this step selected before it, put it right after the step I had selected, but I can just move it easily down here. Okay. Actually, before I do that color match though, let's do something different. Let's use our finder to I can show you how I can find that line in the image. Zoom in on that a little bit. So this is my region of interest here. And you can see it's a little different. It has an arrow in it. Well, I'm going to try to find this line. And actually, I've got find line as the default set for the finder. What this arrow signifies is that the algorithm is going to search in this direction through the image till it finds a line. And you can see it found this edge line right here. But since I want to find this horizontal line, I'm just going to move this that way. And then let's move that to our line. I'm going to change my polarity of the line. I'm looking for the line to go from white to black. Let's change that. I'm going to tighten this area up a little bit. And you can see I've got a good find here, 100% match on that line. Okay, I'm now going to clone that step because I want to find the other line as well. I'll move my color match down below. Let's go to an image where I have a line for the reaction area. I'm going to move my region of interest down there. And you can see I found that line as well. Let's make it a little easier on ourselves. We're going to change this to reference line, and we'll make this one reaction line. And then let's show how we would use our measure function to measure the distance between those two lines. How the measure function works is it can take any of the previously found parameters in the image, features, and measure between them. So you can see I have my pattern match, which was my logo, my decode, or the reference and reaction line. So in this case, I'm going to say let's measure between the reference line and the reaction line. You see my measured distance went to 322, and then this blue line here, we can zoom in a bit more, shows how it measured between the two. I could change the angle on that line by moving these regions of interest to be more in line with each other, more aligned. That would be a little bit better. Okay, now let's get back to my color match, which I started a few minutes ago. So I go to my color match step, and again, just like the other steps, I have a region of interest here. I'm going to move down, and I'm going to modify that region of interest to be as tight as I can around that red bar as I can. And that's because I only want to capture that red color if I can. I don't want to capture the other background color. Then I can go to train color. You can see this is the color right here that it's recognizing, the dominant color in that box. I'm going to add that color to my list. Let's call it reaction color, and close. Okay, now that has established my reaction color. Let's go through the previous. That was my original image. Now here's something interesting. You can see that this area of interest moved because the position of the line in the image moved slightly from the first image to the second image. And you can see that that's a bit of a problem, but I can correct for that. By setting I can anchor. Actually, let me go to the other image. I can anchor this window to the reference line find. Now that area of interest should always be over this line because I'm anchoring it to the line step where we found the line. Let's go to the previous. As you can see now, the region of interest stays on top of the reference line. I'll go to the next, and the next, and the next. So that's good. That stayed on the line like we want it to. We'll go back to our original image. And just like I did before, I'm going to clone that step. Let's go here. Okay, my clone step, now I'm going to move the area of interest down to the reaction line. You see I have a good match here of the reaction line to the reference line. Now let me run the next one though, where I dimmed out that reaction line a little bit. And you can see I get an unknown color because this color departs from that reference color a little bit. But I do get the color distance. And the next one should be an even higher color distance, which it is. So through the project development process, what we would do is use a variety of these different strips with the different reaction colors to determine where is that breaking point, where's the spot where we actually should call that a positive result, and then we could set the color distance to match where it would be positive or negative. Okay, the next thing I should show you is we haven't actually added any output to this script. The output would be really how you want to communicate your results to the host system. So here I'm going to have the output. Now you see you get all these pop-ups, and I can get an output from any of the previous steps. And in fact, I could sprinkle output steps throughout this script. So I can select a few of these things. I think I would probably want to add maybe that I found the cartridge first. So I'm going to add text to the output. Now this is just a free text string. I'll use a little shorthand, cartridge present, space. That was in my present step. I can add the result, add to the output. So now the actual output will look like this, cartridge present, true. In this case, we did find a cartridge. Well, I'm sure I would probably want the barcode decode result, so let's add a little text for that. I'm going to add barcode. Decode message. And there we go. We have barcode, and this was the barcode message. And really along those lines, I could add any of these other steps. I could add, I'm sure I would want to add my color distance. So for my color match, again, I would probably add a text line. I'm not going to do that again because I think you get the idea. But I'm going to add this color match clone and color distance and add that to the output. And so on and so on. I could add as much or little information as I wanted to for the script. One of the things I didn't show you was this count function. And that's really because I couldn't think of a good way to make count make sense with this lateral flow diagnostics example. So I'm just going to grab another image that I have on my hard drive. That's an image of some pills, as you can see here. And I'm going to use the count function, so we'll add that to the end. Oops, well, it added it way up to the beginning, which is okay. I can work on it right there. It added to the beginning because I had last selected this acquire image step. Well, just like with the other plugins, I get my region of interest. I'm going to set that up around the area in the image where the objects are that I want to recognize. Well, you see right away I get all this little noise pops up where the algorithm is detecting just slight illumination variations in the image. I can change some of that. I'm going to go to an adaptive background threshold where now the threshold used sort of adapts across the image for those lighting variations. I still get a couple of them in here, as you can see. Well, what I can do is use these sliders to set a region of interest for really the amount of area that the objects I'm looking for will cover in pixels. So really, how big are the objects I want to see? Well, you can see I change those, I move those up higher, and right away I recognize all these pills. And I'm recognizing from about 30,000 pixels to about 72,000 pixels of coverage for those objects. What I'm going to do is I'm going to move this a little tighter. 46,000 I still recognize. Okay, 54,000, start to lose them. So let's move this up to somewhere in between there. 54, 51. And then I can move this down as tight as I wanted it to be for however discriminating I want to be for the size of those particular objects. Well, that demonstrated all the different plugins here. There's one other thing, that a very powerful feature of Clarity that I did want to show, and that's this test function. And if I go to the test screen and I hit start, what Clarity does, it runs through all the images. Now, I only had 6 images here, but it ran through all of them, and it's going to give me the result of every single step along the way for every one of those images. I could then take all this data, I could put it out in a comma-separated variable file, and I could process that in Excel or a similar program like that. So with 6 images, that wouldn't probably be so necessary, but in a typical machine vision project, you're going to end up gathering hundreds of images or even thousands to see all the different variations in the images to make sure that you get the results that you want. So this is a very powerful feature of Clarity that helps you test all the different variability that you might see on your input images. Well, that concludes our video. I hope this illustrated how you can quickly implement a simple machine vision project, or you could string plugins together to do a more complex kind of machine vision routine using Clarity. And we hope that you would give us a call if you see any need for this kind of capability. Thank you.
Okay, thanks everybody for listening through the webinar again, or the video. Again, this will all be posted up on our website if you wanted to look at it again in the future.
Chuck, thank you for this demo. Are you ready for a question? Because one of our attendees has a question.
Sure, we can answer a question. Then I have a couple case studies that I'm going to walk through.
Oh, great. Shall I just do this question?
Sure, go ahead.
What is the process of getting the script to the camera?
That's a good question. So we have one of the functions I didn't show you in Clarity is that once you're all done and you have that script all fully developed, you can there's a button you select that was up on the top menu screen where you can flash that script down into the camera, and then you would send a command. Your host system would just send a simple command to the camera telling it to execute that script at the right point in your process. The other thing I didn't show you is that you can also do all that testing live with the camera. So
I was using acquired images that were acquired off of my hard drive that I had acquired previously, but you also could acquire an image every time, a new image from the camera. So with that said, I'm going to go through, I have 2 or 3 case studies to show you how we've used Clarity along with our customers to execute a machine vision project. This graphic just really illustrates sort of the spectrum that we generally see for a machine vision project. And it goes really from over here on the right, where we have a customer, they want to do it themselves. So in this case, we deliver Clarity, and then the customer does everything. And that gives the customer ultimate control. And if they have the resources and they believe they have the capability that they can do it that way. On the other end, occasionally we'll get customers that come to us and say, boy, we really just don't have the resources. We need help, and they'll have JADAK outsource the whole project. So what we will do in that case is we use Clarity to solve the machine vision problem. And at the end, we'll deliver the camera and the script and the whole thing to the customer. And then if they have to make changes later on, they can come back to us, or they can take care of it themselves. What we seem to be seeing more and more is this middle hybrid approach, where we'll get a customer that says, yeah, I want to do that machine vision project and I want to have some control over it, but I really don't know how to get started. I don't really know how to do the upfront system engineering and select the camera and the lighting and so on. So in that case, they'll come to JADAK maybe to do some of the upfront stuff, which then we'll deliver to the customer, and then they can take it from there, and which gives them a lot more insight into how the machine vision algorithms are working in their project. I'm going to go through an example of each of those. This first one is way over here on this end. This is the do-it-yourself approach. This customer was developing an automatic slide sortation machine, and they needed to recognize if all of these slides were present in the carrier. And so we delivered Clarity to them, and they used Clarity to detect, they're actually detecting, a little hard to see, these little octagonal shapes on the slides. And they did the whole thing themselves, in which they had the resources to do, and they had the desire to have that full control. When they were all done with the algorithm, there's 2 ways it could go. We could ship cameras to them, and they could flash the algorithm into each one on their own. Or in this case, they sent us their script, and on our manufacturing line, we put the script in the camera, ship it to them, and then they have a camera that's all ready to install. They don't need to do any extra operation. This is the middle approach here, the sort of a JADAK OAM partnership. And this was for a Chinese customer. This graphic here shows a line of people at a Chinese hospital. Of course, everyone knows there's a lot of people in China, and their hospitals tend to be a little bit crowded. And these people are all just waiting in line to give blood that can be tested for whatever is bothering them. In order to try to ease some of this congestion in those lines, our customer was making an automatic tube sortation machine. Depending on what you want to test the blood for, you're going to use one of these different tubes, and the cap color and so on is significant for how the ultimate processing through which that sample is going to go. This was one of those customers that came to us and said, yeah, we want to do a lot of this machine vision work ourselves, but we don't really know how to get started. So how this works is JADAK developed the initial system engineering. We developed a test fixture on which the camera was mounted and the test tube was mounted. We gathered the initial images and developed the initial Clarity script, which we then delivered that whole thing to the customer. And they were able to take it from there. So then they gathered all their subsequent images and did the subsequent modifications to the algorithms as needed. So again, this worked well for them because they didn't want to get black box. They wanted to have more insight to how the machine vision worked, but they needed a little help getting up and running. And then this last case study is a full turnkey example, way over here on this left end of the spectrum. What this customer was doing, they had an in vitro diagnostics machine, and they wanted to detect whether their reagent pack was present in the machine or not. This is just a simulation we did of their reagent pack. this customer said, well, we just don't have resources. We're struggling to get our project done. JADAK, can you do this whole thing for us? Which we did. So we did all the upfront system engineering. We developed the test fixture. We gathered the images, developed the machine vision script, did all the testing and all the regression testing whenever any changes were made. And at the end of the project, deliver that whole thing to the customer. So now they have that, and if they have subsequent changes to their product, they can make any necessary machine vision modifications as needed, or they could come back to JADAK for those as well. Okay, that's the end of the presentation, and we'll take any questions that may have come up, additional questions that may have come up during the last 40 minutes.
Yeah, Chuck, I have some questions here of our attendees. One of the questions is, can we have a free demo to test it?
Well, certainly, I think our what we would want is to have our application engineers talk to you, understand what machine vision problem you're trying to solve, and they would definitely work with you to get clarity to you so you could try it out.
Okay, thank you. And another question I have here is, how can I purchase the software to use with one of your JADAK cameras?
Yes, so that's a similar answer to the last one. Again, we would first want to do a quick consultation with you to decide if clarity is the right approach and if it'll work for you. And then depending on your business case, our account managers would talk to you about how we would approach the project after that.
Okay, thank you. And one more question. How many kind of cameras support this software?
Oh, good question there. So if you looked on our website, you'd find 4 main cameras that are supported. It's our FM5, our FM6, our SC6, and our Vibe cameras are supported. Those are all available on our website. And as we introduce more cameras in our product line, that'll continue to be added.
Thanks, Chuck. I have one more question. The question is, I saw at the presentation it's possible to match 8 colors. Can the camera detect more different colors than that 8?
Yes, we can. We can detect many colors. I'm actually not even sure what the upper limit is on that. So that's maybe one that we can get an email to you to tell you what the upper limit is. I don't know it off the top of my head.
Okay, thank you. Yeah, I believe that's it. No more questions. Then I would like to say at this time, thank you to all of our attendees for joining the webinar today. And special thanks to our presenter, Chuck Barber, for his presentation and demos. A recording of this session will be automatically emailed to all those who registered for the event within the next week. If you have further questions on Clarity software, machine vision, or any of our other technologies, we invite you to visit our website jadaktech.com or schedule a tech day with us by emailing at techday@jadaktech.com for free technology consultation. Thanks again for attending and have a great day.